Okay, think about this for a second. What if the future of energy, all of it, wasn't powered by some super rare metal, but by something you literally have in your kitchen right now? Yeah? Today we're diving deep into the truth about sodium-ion batteries.
I mean, let's be real. Right now there's one king of the battery world, and it's lithium-ion. Look around you. The phone in your hand, that laptop, maybe even the car in your driveway. It all runs on this one undisputed champ. It's the tech that literally untethered our modern lives.
But, every king has a challenger, right? And there's a new one stepping into the ring, a contender that promises to fix some of the biggest nagging problems with our current battery tech. So the big question is, are we looking at a full-blown revolution here?
All right, so before we get to the future, we've got to understand the present. Let's talk about the world that lithium-ion built.
And let's give credit where credit is due. Lithium-ion tech was an absolute game changer. I mean, it packed a crazy amount of power into smaller and smaller spaces. Without it, there's no smartphone revolution, no lightweight laptops, and no making electric cars a real thing. It was huge.
But there's always a but, isn't there? This dominance has some serious hidden costs. For one, lithium isn't exactly growing on trees. It's kind of rare, and the supply chains are, well, let's just say they're fragile. And then there's the safety stuff. You probably heard the term thermal runaway. That's the scary part, when a battery overheats and catches fire, and it's incredibly hard to put out. So yeah, there are some real downsides.
And that brings us to the challenger, a technology built on, believe it or not, one of the most common materials on the entire planet.
So let's meet the sodium-ion battery, or SiB for short. And what's really wild is that under the hood, it works pretty much the exact same way as a lithium-ion battery. You've still got these little ions shuttling back and forth between an anode and a cathode to store and release energy. The only difference, and it's a huge one, is that it uses sodium ions instead of lithium ions.
And this is the mic drop moment. Where do you find sodium? Everywhere. It's in the ocean, it's in table salt, it's literally the 6th most abundant element on the whole planet. We are never going to run out of sodium. This just completely flips the entire resource game on its head.
Okay, so once you grasp that, all the other advantages just kind of fall into place. The raw material, it's dirt cheap and, as we said, everywhere. That means the batteries themselves are going to be way cheaper. And get this, they're also inherently safer because they have better thermal stability. Plus, they work better in a wider range of temperatures, hot or cold.
Let's talk money, because this is where it gets really interesting. The long-term projection? We could see these battery packs costing less than $40 per kilowatt hour. Now, that might just sound like a number, but trust me, that is massively disruptive. That's the kind of price point that makes huge grid-scale energy storage, well, actually affordable. It changes the entire economic equation for renewables.
All right, so we've got the reigning champ and the up-and-coming contender. Let's put them head-to-head.
First round, materials, and this is the big one.
Lithium is a bottleneck, pure and simple. It's mostly found in just a handful of places around the world. Sodium, it's the complete opposite. It's everywhere, for everyone, a truly limitless resource.
Round 2, safety. This is huge. Because of its chemistry, sodium ion is just way less likely to do that scary thermal runaway thing, overheat and catch fire. This makes it a much, much safer bet, especially when you're talking about packing thousands of these things together for grid storage.
But here it is, the big trade-off: performance. Here's the best way to think about it. Lithium-ion is like an Olympic athlete. It's super lean, light, and powerful. It's got what we call high energy density. Sodium-ion, it's more like a workhorse. It's incredibly strong, but it's also heavier. Its energy density is lower, which means for the same amount of power, the battery's got to be bigger and heavier.
And that trade-off, that's the whole key right there. Because it shows us this isn't a fight to the death. It's not about one battery replacing the other. It's about finding the right tool for the right job.
Yeah, if you remember one thing, make it this. It's not about replacement. It's about reinforcement. Sodium ion is here to back up the team, to play a position where lithium ion, well, just isn't the star player.
So what does that look like in the real world? Well, lithium-ion stays the king, where being small and light is absolutely everything. Think your smartphone, your laptop, those sleek, high-performance EVs. But sodium-ion, it's going to be the star in places where weight doesn't matter as much, like storing massive amounts of energy for the power grid, or in smaller, low-cost EVs and scooters, where making it affordable is way more important than making it super lightweight.
So what does this future built on salt actually look like? Well, you might be surprised, it's happening a lot faster than you think.
This isn't some far-off dream. The ball is already rolling. In just a couple of years, by 2026, we're going to see a huge surge in sodium-ion for grid storage. By 2030, it'll be a big deal in affordable electric vehicles. And by 2035, it'll probably be a fundamental piece of the puzzle holding up our entire renewable energy grid.
And that's really why all of this matters so much. The big takeaway here isn't about one battery winning and one losing. It's about having two powerful, specialized tools working together. Lithium will keep powering the devices in our pockets, and sodium will power the grid that charges them. And the result? A cheaper, safer, and way more stable energy future for all of us.
So as we finish up, let me just leave you with this one last thought. It's funny, right? We're always looking for these complicated, high-tech, exotic answers to our biggest challenges. But maybe, just maybe, for one of our biggest problems, energy storage, the answer has been hiding in plain sight this whole time. In something as simple, as humble, and as common as a grain of salt.